Ready? In offline class, I had discussed up to question number 42. Next question is 43. And question is, which of the following is isoelectronic as well as isostructural with N2O? Listen, N2O, number of electron in N2O will be 2 into 7 plus 8. Yes or no? It will be 22. Now, option number first, N3H, it has also 22 electron. H2O, it has 10 electron. NO2, (23 electron). And carbon dioxide has 22 electron. Listen, question is, which of the following is both isoelectronic and isostructural? For isoelectronic, number of electron will be same, but N2 has 22 electron, water has 10 and hence not isoelectronic. 23 electron, not isoelectronic, but there are two options, N3H and carbon dioxide. Both have 22 and 22 electrons. Clear? No. Both are isoelectronic with N2O, but question is कि both isoelectronic and isostructural. The N2O has linear. It is linear, and N3H has bent structure, and carbon dioxide has linear structure, and hence answer of the question will be carbon dioxide, because both are isostructural and isoelectronic. Clear? Clear? Listen. Both N2O and carbon dioxide are isoelectronic and isostructural. Next question. Question number 44. Question number 44. A sample of gas has a volume of 0.2 liter. Sample of gas has a volume 0.2 liter. Listen. A sample of gas has a volume 0.2 liter. Volume is equal to 0.2 liter. It's measured at 1 atm pressure and 0 degree C. Pressure is equal to 1 atm and temperature is equal to 0 degree C. That means 273 Kelvin in Kelvin, because given 0 degree C. The same pressure, that means P is constant. Pressure is constant. But at 273 degrees C, listen, it is V1, P1, T1. T2 is 273 degrees C. It will be 273 plus 273. Clear? That means it will be 6, 4 and 5. 546 Kelvin. 546 Kelvin. The volume will be, now listen, in this question, pressure is constant. Pressure is constant. When pressure and mass of the gas is constant, then applied Charles' law. And Charles' law is, listen, V1 T1 is equal to V2 T2. And V1 is 0.2 liter, T1 is 273 Kelvin, V2 and T2 is 546 Kelvin. The calculation, listen, 273 twice 546 and 0.2. 2 and 2 cancel 1. That means V2 is equal to 0.1 liter. Check it option. V2 is equal to 0.1 liter. Option number A. Clear? Option number A. Write down. Again repeating. V1 0.2, P1 1 atm, T1 0 degree, 273 Kelvin, pressure constant, T2 273 degree C, that means 546 Kelvin. At pressure constant and mass constant apply to Charles' law, V1 T1 is equal to V2 T2, and hence answer of the question will be 0.1 liter. Next. Listen. Next question. If the absolute temperature of gas is doubled and pressure is reduced to 1/2, then the volume of gas will be. Listen, from ideal gas equation, volume equal to nRT by V. nRT by P, not V. nRT by P. That means V1 is equal to nR T1 and P1. Equation number first. Now, according to question, the absolute temperature of a gas is doubled. V2 N R, and absolute temperature double. That means T2 is equal to 2T1. According to question, T2 is equal to 2T1. That means double of initial temperature. Pressure is half. Here is P2 and P2 is P1 by 2. Yes or no? And after calculation, it will be nR 4 T1 by P1, and it is second. After dividing by first and second, V1 by V2 is equal to nR T1 by P1 by 4 into nR T1 by P1, and what nR T1 P1 cancel. That means V2 is equal to 4 V1. V2 is equal to 4 V1. Clear? Answer is remain unchanged, no. Be doubled, no. Increase 4-fold and reduce 1 by 4. That means V1 into 4. V2 is equal to, that means increase 4-fold, and correct answer will be C number. Clear? Clear? Next. 46 number. Listen. Question number 46. And 46 number is, Dalton's law of partial pressure is not applicable for. Listen carefully. Dalton's law is applicable for non-reacting gaseous mixture and not applicable for reacting gaseous mixture. I am repeating. Dalton's law applicable for mixture of non-reacting gases and not applicable for mixture of reacting gases. Dalton's law of partial pressure, always keep in mind, only applicable for mixture of non-reacting gases and not applicable for mixture of reacting gases. Clear? Question is, Dalton's law of partial pressure is not applicable for, that means for reacting mixture. Option number A, ozone and oxygen. Ozone and oxygen react in particular condition, but normally do not react and hence applicable. But question is not applicable. Carbon monoxide, carbon dioxide normally do not react both gases. NH3 and HCl. NH3 and HCl are mixture of reacting gases. Look at the word. NH3 plus HCl, after reaction it gives NH4Cl. NH3HCl after reaction gives NH4Cl. Both gases are reacting gas and hence Dalton's law not applicable. Because Dalton's law, always keep in mind, Dalton's law only applicable for mixture of non-reacting gases. And question is not applicable and hence for mixture of NH3 and HCl, Dalton's law not applicable because both are reacting gases. Next, equal mass of ethane and hydrogen. Equal mass of ethane and hydrogen mixed in an empty container. Equal mass. Ethane, let C2H6 x gram, let us x gram, and also H2 x gram. Both are equal. According to question, equal mass of both mixed. The fraction of partial pressure of hydrogen is, listen, are you know about partial pressure? Listen, partial pressure is mole fraction into total pressure. But when total pressure is not given, then mole fraction is equal to pressure fraction. Mole fraction is equal to pressure fraction. And what is mole fraction? Listen, mole fraction, look at board, mole fraction is equal to individual mole dividing by total moles. Individual moles dividing by total moles. Clear? Now, moles of C2H6, that means mass x gram and molecular mass 18. Gram cancel, x by 18. Moles of H2, mass x by 2, not 1. Because gas is made up of molecules, molecular weight, the x by 2. Clear? Now, what will be mole fraction? Always keep in mind, mole fraction is equal to pressure fraction. Mole fraction is equal to pressure fraction. The topic is the fraction of partial pressure of hydrogen is fraction of partial pressure. That means mole fraction of H2. The moles of H2, x by 2, dividing by moles, x by 2 plus x by 18, x by 2, and from denominator, LCM will be 18, and it is 9x plus x, it will be 10x. After calculation, it is x by 2 or into 10x by 18 and it is 18. X and x cancel. And after then it will be 18 by 20. 18 by 20. And 18 by 20 means 9 by 10. Answer will be 9 by 10. Check it. 9 by 10. But in your question, no any option is 9 by 10. But answer will be 9 by 10. Mole fraction is equal to pressure fraction. And hence answer will be 9 by 10. Write down. Next. Clear? Equal mass, mole of this, mass by molecular mass, mole of this, mass by molecular mass, mole fraction, individual mole by total mole fraction of H2 equal to 9 by 10, and hence answer will be 9 by 10. Clear? Next question. Listen. Molecular weight of gas diffuse twice as rapidly the gas with molecular weight 64 is. Listen. Question number 48. From Graham's law of diffusion, it's part of gaseous state. Listen. Graham's law of diffusion is R1 by R2 is equal to root under M2 by M1. Clear? This is formula of Graham's law. And question is 48 number. Molecular weight of a gas that diffuse is as rapidly the gas with molecular weight 64. Let us consider R1 has rate X. Let a gas of which rate R1 and molecular weight 64. Let a gas of rate R1 and molecular weight 64. And question is molecular weight of gas that diffuse twice. Now R1 and R2 diffuse twice. That means R2 equal to 2R1. According to question, the second gas diffuse 2 times rapidly. That R2 equal to this. Now, root under M2 and M1 is given 64. Yes or no? No. R1 cancel. That means 1 by 2 is equal to root under M2 by 64. Yes or no? Next. Root. After calculation, it will be 1 by 4 and M2 by 64. That means M2 is equal to 64 by 4 and it will be 16. 16. Yes or no? That means molecular weight of the gas is 16. Check it. Check it. Option number A, 16. Write down. It's part of Graham's law of diffusion. R1 by R2 is equal to root under M2 by M1. Gas A, let us consider rate R1, molecular weight 64. Second gas 2 times rapidly diffuse. That means R2 equal to 2R1 and M2 value is 64. Clear? Next. Next question. 50 ml of gas fused through membrane in the same time 40 ml of gas B under identical pressure temperature condition. If the molecular weight of A is 64, then B. Listen. In previous question, it is this question also from Graham's law of diffusion. Clear? And formula is, listen, R1 by R2 is equal to root under M2 by M1. Clear? R1 by R2 is equal to root under M2 by M1. But R is rate of diffusion. And look at what? Rate is defined as volume of gas diffused dividing by time. Volume of gas diffused dividing by time. Then R1 by R2 root under M2 by M1, and R is volume of gas diffused by time. In your question given gas A, that means RA by RB is equal to MB by MA. Yes or no? Both are same. 1A, 2B, MB by MA. Now, in your question given 50 ml of gas A diffused through membrane in the same time 40 ml of B. Listen, 50 ml, the 50 by time dividing by 50 by TA and 40 by TB is equal to MB by MA. And in your question clearly given, time both gas is same. That means TA and TB are cancelled. Time of both are same and hence both are cancelled. Now after calculation, it will be, listen, 50 by 40 is equal to MB and molecular weight of A is 64. That means it is 64. 0, 0, cancel. When we cancel to root, then it will be 5 square by 4 square is equal to MB by 64. MB is equal to 5 square into 64 by 16 and 16 4 ja 64 and 5 square 25 into 4 it will be 100 and molecular weight of B is 100. Check it. Molecular weight of B is 100. Check it. Option number A. Molecular weight of gas B is 100. Clear? Again, this is formula of Graham's law. Rate is volume by time. Rate diffusion, volume of gas diffused by time. In case of mole, then mole of gas diffused by time. So R, volume by time. R for B, volume by time. MB by MA. In your question, time is same. Time cancel, and after calculation, molecular weight of B is how much? 100. Clear? Next. Very simple. Postulate of kinetic theory of gas. Kinetic, not gas. Postulate of kinetic theory. And kinetic theory is given for gas. Option first. Atom is individual. It's not kinetic theory. Number 2. Gases combine in simple ratio. It's not a kinetic theory. There is no influence of gravity. Yes. Option number C, kinetic theory of gas is, listen, about gas. Listen. Why option number C? Look at both. What is kinetic theory? Let us consider a container and it's a part. In upper section, gas A, molecular weight Ma, and pressure of gas Pa. In lower section, gas B, molecular weight of gas B is Mb and pressure is B, Pb. Clear? If Mb, that is molecular weight of gas B, very much heavier than A, very much heavier than A. And when the container is opened, this wall is opened, gaseous molecule exert pressure on this wall. That means gaseous molecule collide with this wall and this molecule collide with this wall. When the wall is opened, then gas B, but heavy gas B mixed and goes to upper section. Lighter gas goes to lower section. And hence, gases, always keep in mind, gases do not obey law of gravity. Gases do not obey law of gravity. Gas do not obey law of gravity. It's part of kinetic theory of gas. Next. Listen, real gas most closely approaches the behavior of ideal gas. Listen, real gas do not obey ideal behavior, but real gas obey ideal behavior. Listen, low pressure and high temperature. Again, I am repeating. Real gas obey ideal gas equation, low pressure and high temperature. Why real gas obey at low pressure and high temperature just like ideal gas? Listen, difference between ideal and real gas. In ideal gas, volume of gas molecules negligible with respect to total volume of gas. In kinetic theory, volume of gas molecule negligible with respect to total volume of gas. But according to van der Waal, when total volume of gas is less, then volume of gas is not negligible. Gas molecules not negligible. In case of low pressure, at low pressure, volume will be high, and high temperature volume will be high. So at high temperature and low pressure, total volume of gas will be very large, and hence volume of gas molecules negligible, and real gas obey just like ideal behavior. One more point. In kinetic theory, there are no any attractive and repulsive force arises between gas molecule. There are no any attractive and repulsive force arises between gas molecule. So at low pressure and high temperature, when volume of real gas would be very large difference between gas and gas molecules, and hence no any attractive and repulsive force arises between gas molecules, and hence, listen, real gas obey ideal behavior at low pressure and high temperature. Low pressure and high temperature. 15 atm 200 Kelvin, 1 atm 273, 0.5 atm and 500 Kelvin. Clear? Low pressure and high temperature, and hence answer will be C, because in deep 15 atm 500 Kelvin, and hence answer is low pressure, high temperature. Answer will be C, 0.5 atm and 500 Kelvin. Clear? Next. Air at sea level. Listen, it's common question. Air at sea level that means 760 mm, 1 atm, is dense. This is practical application of, because sea level that means pressure is constant, 1 atm, and 1 atm means Boyle's law, pressure constant not, it is density. So pressure constant, Charles law, and hence it is application of Charles law. Clear? Because pressure is constant. In Boyle's law, temperature and mass is constant. Next. In which reaction the yield of product does not increase by increase in pressure? Listen, question number 53. It's part of chemical equilibria and in chemical it will be a Chatelier principle. Chatelier. Listen, Chatelier principle and point of pressure. With increase in pressure, listen point. I am writing. With increase in pressure, equilibrium shifts that direction. Equilibrium shifts that direction where less number of moles present. Always keep in mind, point of pressure. With increase in pressure, equilibrium shift in that direction where less number of moles present. I am repeating. With increase in pressure, equilibrium shift in that direction where less number of moles present. Listen, and H2 plus I2 convert into 2HI. Look at board. In this side, 1 plus 1, 2 moles. Right side, product side, 2 moles. That means both side number of moles are equal. Both side number of moles equal. And hence, with increase in pressure, equilibrium do not affect it. I am giving concept of Chatelier pressure point. Listen, with increase in pressure, equilibrium shift in that direction where less number of moles present. In this reaction, both sides same number of mole present, no effect of pressure. But second example, N2, 3H2, 2NH3. Listen, in reactant side, 1 plus 3, 4. Right side, 2. That means product side less number of mole. With increase in pressure, equilibrium shift to right. With increase in pressure, equilibrium shift to right. That means formation of ammonia will be occur at high pressure. Matlab formation of ammonia, favorable condition is high pressure. And when ammonia dissociate, look at both 2NH3 N2 plus 3H2, left side 2 moles, right side 4 moles. When pressure increase, equilibrium shift to backward because less number of mole present, 2 moles, right side 4 moles. With increase in pressure, equilibrium shift in that direction where less number of moles present. The less number of mole, right side, with increase in pressure, right. Both sides, same number of mole, no effect. Left side, less number of mole, with increase in pressure, it will be a shift to left. Now, your question and your option. Check it. Question is, in which reaction the yield of product does not increase by increase in pressure? Does not increase. That means maybe decrease and maybe constant. So that means product. So with increase in pressure, it will be a shift in less number of mole side. So when product side more number of moles, then with increase in pressure, it will be a product not increases. Option number first. I am writing. First option PCl3 plus Cl2 PCl5. Second option N2 plus O2 2NO. Third option 2SO2 plus O2 2SO3. And last option N2 plus 3H2 2NH3. There are 4 options. Again, I am repeating point of Chatelier of pressure point. With increase in pressure, it will be a shift in that direction where less number of mole present. Listen, 1 mole, left side 2 mole. With increase in pressure, it will be a shift to right. That means product increases. But in your question given to not effect, that means answer O is, sorry, first is not correct. In second, 1 mole, 2 mole. 1, 1, 2 and 2, both sides same. With increase in pressure, equilibrium do not affect it. And hence answer B correct. But I will check answer number third and fourth. 2 and 1, 3 mole, 2 mole. That means less number of mole. With increase in pressure, equilibrium effect to this side, that means product increases. And hence C number is not correct. 1 and 3, 4 mole and 2 less number of mole. And hence with increase in pressure, equilibrium shift to right. That means increases. Answer number B is correct. Always keep in mind, Chatelier, it is point of pressure. With increase in pressure, again I am repeating, with increase in pressure, equilibrium shift to that direction where less number of moles present. Clear? Next. For reversible reaction, if concentration of a reactant is doubled, then equilibrium constant will be, look at board. Listen, a reversible reaction, A convert into B. Listen, time बराबर 0, conc A and 0. Listen, A convert reversible B, time is equal to 0, conc A, 0. At equilibrium, it will be A minus X and X. Kc equal to conc of B by conc of A. But always keep in mind, it is equilibrium conc, not initial conc. Equilibrium conc and equilibrium. That means it is X by A minus X. Clear? That means Kc depend upon equilibrium conc, never depend upon initial conc. In your question given, for reversible reaction, if conc of the reactant is doubled, conc of reactant, that means this A is doubled. Clear? The equilibrium constant will be, answer will be same, because equilibrium constant do not depend upon initial concentration. If in a question given ki equilibrium conc, listen, always keep in mind only one thing, equilibrium constant do not depend upon concentration. Equilibrium constant only depend upon temperature, not depend upon concentration. Answer will be when equilibrium conc double, equilibrium constant unchanged, that means same. And answer of the question is last number, D number, same. Always keep in mind equilibrium constant do not depend upon conc of reactant and product, it's depend upon only temperature. Clear? Next, if the reaction and reaction is N2O4, I am giving concept for the question. Alpha is the N2O4 which dissociate, then the number molecules, yeah, molecular equilibrium will be, first, alpha is N2O4 which dissociate. Part of N2O4 means degree of dissociation. Always keep in mind, alpha is degree of dissociation. And one thing, write down on notebook, degree of dissociation, degree of dissociation, and degree of dissociation is equal to number of moles dissociates by initial number of moles present. Again, what is degree of dissociation? Number of moles dissociate dividing by initial number of moles present. Number of moles dissociate by initial number of moles present. Clear? Question is N2O4. Look at both. And dissociate into 2NO2. Clear? Calculate the N2O4 which dissociate the number of molecular at equilibrium. Listen. If time equal to 0, it is 1 and it is 0. After dissociation, that time 0, that means before dissociation. And after dissociation, if it is 1 minus alpha, then 1 to 2, it will be 2 alpha. And total moles at equilibrium, yeah, after dissociation, 1 minus alpha plus 2 alpha. Listen, 1 minus alpha forms a coefficient 2 alpha. And after addition subtraction, it will be 1 plus alpha, and hence answer is 1 plus alpha. Clear? Answer is 1 plus alpha. Write down. Clear? Next, 56. Listen. For exothermic reaction, an exothermic reaction is NO gas convert into N2 gas, O2 gas, and plus heat. It is exothermic reaction. Clear? Clear? Question is, K is independent from temperature. Listen, it's part of chemical equilibria. It's part of chemical kinetics. One equation is Arrhenius equation. Look at both. Log K2 by K1. Log K2 by K1 is equal to delta H, या Kc2 by Kc1. Kc2 by Kc1. Delta H by 2.303 R 1 by T1 minus 1 by T2. Clear? Look at both. Easy. Take easy. Listen. When delta H negative, delta H negative, that means this part is negative, upper part, and T2 greater than T1. T2 greater than T1. So this part negative. When T2 greater than T1, that is 1 by T2 less than 1 by T1. Yes or no? T2 greater than T1. That means 5 greater than 2. Then 1 by 5 less than 1 by 2. T2 greater than T1. So 1 by T2 reciprocal of large number will be a smaller. Clear? So 1 by T2 and 1 by, listen, 1 by T2. When T2 greater, 1 by T2 is smaller, that means minus sign is smaller, and delta H negative, the under bracket, when T2 increases, under bracket it will be positive. And negative positive multiplied by negative. That means, listen, log K2 minus log K1 is equal to negative. That means K2 minus K1 is equal to negative. That means K1 is greater. Clear? In simple statement, when delta H negative, then with increase in temperature, value of K decreases. Value of K decreases. Because when negative, difference of negative, K1 greater, because K1 has negative sign. Simple. When delta H negative, that means exothermic reaction. In case of exothermic reaction, when always, when in case of exothermic reaction, when temperature increases, value of K decreases. Temperature increases, value of K decreases. And when delta H positive, when it is positive, listen, positive and T2 greater, so this is positive, under bracket positive, oval or term positive, positive multiplied by positive, difference will be positive, that means K2 greater. So when endothermic reaction, in endothermic reaction, temperature increases, K increases. Exothermic reaction, temperature increases, K decreases. It is concept. No, your question. For exothermic reaction, keep in mind exothermic. Temperature increases, K decreases. First, K is independent from temperature. No. Exothermic, temperature increases, K decreases. K increases, temperature increases. No. K decreases as temperature increases. Yes. Why? Because it's your formula. If any dots, then you meet me tomorrow physically. But next, always keep in mind, again I am repeating, exothermic, delta H negative, temperature increases, K decreases. Temperature decreases, K increases. Endothermic, delta H positive, when temperature increases, K increases. In endothermic, temperature increases, K increases. Temperature decreases, K decreases. For oral and for memory, when delta H negative, always keep in mind, negative. Temperature increases, temperature increases, K decreases. When delta H negative, increases, decreases. When delta H positive, increases. Clear? Next. For the reaction, copper, Ag, copper, and copper is solid form, plus 2Ag plus aqueous, copper plus aqueous, plus 2Ag solid. It's your question. The equilibrium constant Kc is given by, listen, very simple. Very simple. During representation of Kc, solid reactant product ignore. Solid reactant product and along with pure liquid reactant product. During Kc representation, solid ignore, pure liquid ignore. In your question, reactant side, left side carbon solid, ignore, right side Ag ignore, then what will be Kc? Kc of the is copper plus plus and dividing by Ag plus and square. Clear? It's formula of Kc. Again, your question, copper solid to Ag aqueous, copper aqueous to Ag solid. What will be? The copper plus dividing by Ag plus square and answer number C. C number is correct. Clear? Clear? Next. The equilibrium constant for the reaction, this equilibrium constant for this relation. That means it's a part of chemical equilibria. Look at about equilibrium constant for the reaction N2 plus 3H2. Look at about N2 plus 3H2, 2NH3. Equilibrium constant is K. Clear? Now the equilibrium constant for the reaction. Look at about NH3. convert into half into plus 3 by 2 H2. What will be equilibrium constant for the reaction in terms of K? Listen. First check relation between both equations. First equation and second equation. Second equation is, there are two relations. First is reverse of above equation, reverse, and hence equilibrium constant of this, equilibrium constant of this is reverse, that means 1 by K, first part, but not only in reverse form, reverse and 2 convert into, there will be 2 by 2, and dividing by 2, 1 by 2, 3 by 2, that means reverse and dividing by 2. So when a reaction is reverse and dividing by 2, then equilibrium constant of bottom reaction 1 by reverse, that means reciprocal, and dividing by 2, that means a square root. It may be written as 1 by K to the power half. K to the power half. That 1 by root K. 1 by root K. Check it option. 1 by root K. Answer number D. 1 by root K. Answer number D. Clear? Next. For the reaction N2 itna heat. It is for the reaction. Clear? Reaction reverse, dividing by 2, reverse, that means reciprocal, and dividing by 2, that means power 2, that means square root. And hence answer number D. Next. 59. Relation between Kp and Kc. First concept, Kp equal to Kc into RT to the power delta N. It's a formula. Formula of relation between Kp and Kc. And your question is N2, 3H2, 2NH3. What will be delta N? Coefficient of product 2 minus 1 plus 3. It will be minus 4. It will be minus 2. Minus 2. Clear? Now, what will be relation? Kp is equal to Kc into R2 to the power minus 2. RT to the power minus 2. Clear? Check it option. First option no, second option no, third option Kc to the minus 2. And hence option number C is correct. Write down fast. Clear? Clear? Next, last question and 60 number question. And 60 number question is, in the reaction A2 plus 4B2 convert into 2AB4 and delta H is negative. Delta H is negative. Clear? Listen. What will be favorable condition for AB4 formation? Clear? Listen. Option I will check later, but again, there are two parts, temperature and pressure. Always keep in mind, favorable condition. With increasing pressure, it will be a shift to that direction where high number of moles, with increasing pressure, it will be a shift in that direction where less number of mole present. 4 and 1, 5 mole, right side 2 mole. That means with increasing pressure, it will be a shift to right because less number of mole. Again, 4 and 1, 5, 2. Less number of mole, and hence at high pressure forms maximum. That means it is favorable condition, high pressure. Clear? Next, delta H is negative and When delta is negative, then temperature increases, K value decreases, and product formation decreases. When delta is negative, then at low temperature, product form maximum. Because when delta is negative, temperature increases, K decreases. And low temperature, K will be high. And hence product will be high. That means favorable condition is for formation high pressure and low temperature. High pressure and, check it option, high pressure and low temperature. Check it answer. High pressure, low temperature, high pressure. Yes, low temperature, first option. Second, high temperature, low pressure. No. Low temperature, low pressure, height. No. First option is correct. And all 60 questions discussed physically and online class. If any doubts, any discussion, then you all are meet with me, 5th floor, teacher's room. Okay? Good night. Take care.
Ay, ang mga dito na